Hi, this is Emma Vierheller, and this is my final project. I've recorded a presentation for you that takes a look at mathematical modeling and how the Mathematics Vision Project curriculum uses modeling and an analysis of how successful I think it is, given some information that we're going to talk about in regards to modeling. So what I want to go through in this presentation is we're going to review some Common Core standards that are relating to modeling, specifically in geometry. Modeling is its own thing in the Common Core, but we're going to look specifically at within geometry. Some research about modeling. I want to introduce you to the curriculum that I'm going to be analyzing, and then the bulk here is how does this curriculum attack modeling? Is it doing a good job of working through modeling, and what are some improvements that can be made? So the first thing we'll go through are the Common Core standards relating to modeling. So these should be familiar. So we're applying modeling using shapes. We're describing objects. We're looking at density. And then kind of the big one is the bottom, apply geometric methods to solve design problems. Designing an object or structure to satisfy some constraints. Kind of working within, okay, here's these geometric ideas. How can we apply them? And then we're also going to take a look at two-dimensional and three-dimensional objects. So, want to go into some of the research about geometric modeling and mathematical modeling in general. This is going to get applied to geometric modeling, but we want to talk a little bit about modeling in general. It's a hot topic in mathematics. So, the GAME report, the Guidelines for Assessment and Instruction in Mathematical Modeling Education, kind of one of the premier research organizations that are taking a look at what should students be doing when they're modeling. And so their definition of modeling is that it's a process that uses math to represent, analyze, and make predictions or otherwise provide insight into real-world problems. And so there's a lot going on there, and within our mathematics we often try to look at the real world and we're not always super successful, but that's kind of the standard that we're going to be taking a look at is what in terms of what mathematical modeling is. And how that looks, how students engage in modeling. So here's a framework that we've got. So students are identifying and specifying a problem, they make some assumptions, they're doing the math, and then you can see that this is an iterative process where they're going back. They might need to make new assumptions. They might need to go back and re-identify the problem. Maybe they don't understand that. So this gets super messy super quickly. And one of the things that I like about this specific framework is it's really similar to the engineering design process that I use when I'm teaching my pre-engineering course here at Penta, is that the process is supposed to be super messy and it's supposed to get gross and we're supposed to have to make some assumptions and go back and do different ideas, and then finally we're going to be determining whether or not our final solutions are valid. So this is what one way of thinking about what students are doing in modeling. There are other frameworks as well. And then also importantly is what are we doing? How do I know if modeling is actually happening in my classroom? I'm sorry that my little corner piece is kind of touching the screen there. So are my students starting with something messy? Are they making assumptions? Are they identifying what changes and stays the same? Who are they communicating with? Does their answer make sense? Are they choosing the right tools? Have they revised their model? So these are the questions that we should be asking. If this modeling idea is being successful in our classroom, we should be able to answer these questions affirmatively. And that's something that might not always be true when we think we're engaging in some modeling. And we're going to think about this a little bit as I introduce the MVP curriculum. So there are a couple tensions here in what real world means with modeling. According to the GAME report, modeling needs to be based in something real world. And there's this tension of what is real world, what isn't real world. Are the textbook questions that are the problems that we sometimes skip the end of the textbook that kind of sort of try to bring in the real world, but we know it's fake. If it is fake, is that modeling? Are we trying to put something that's real world? Not. These are messy questions that I thought about a lot while I was working through this project, and something I think about a lot with my students. Is it better to put something that's not real world, or is it better to put something that kind of sort of is contrived real world? And if you want to talk more about this, Dan Meyer on his blog, I will sing his praises to the top of the world, talks a lot about what needs to happen in for real world to be modeling. And he came out against the GAME report and said it doesn't have to be real world. We model all the time without a real world context, which can be kind of freeing sometimes. But it's worth you taking a look at and thinking about on your own. So Next thing I want to show to you is the Mathematics Vision Project curriculum. This is a curriculum that I use in both my algebra and geometry classes, not exclusively, but it's a curriculum that puts a task front and center in what the students are doing. That's something that I've really enjoyed, but as you'll see, it's also far from perfect. So here's from the Mathematics Vision Project website what the classroom experience is for students. I'm going to talk through this a little bit. I'm going to leave it on the screen long enough so you can read through it. So students are using a task to develop ideas, to think about what might need to happen mathematically. There is very little giving of formula. There is very little direct instruction occurring. The task is supposed to lead them to the mathematics that's important. And that's something that I've come to value a lot, and I know a lot of math teachers have. And while the value is there, it can be really difficult to do this. So one of the reasons why I employ the Mathematics Vision Project curriculum is it gives me a starting point. So throughout a unit, students are introduced to perhaps a new idea, and then subsequent tasks build upon that idea. It's supposed to be a lot of conversation. It's supposed to be some stuff that isn't right away. It's supposed to be doing that depth versus breadth thing that we ascribed or attributed to Common Core state standards allowing us to do, but it's not always true in practice. So that's what the Mathematics Vision Project is about. I also want to show you a couple of the things we do so you get the idea of what's happening in a classroom. So here's an example from the Modeling with Geometry unit. So students are given the cross-section of a flower vase. We've talked a little bit about cross-sections, 2D, 3D, solids of revolution, which is, I think, super cool because it alludes to calculus without getting there. And so students needed to find the cross-section of a flower, or find the volume of this flower vase. They know they're not going to be right because it can't be perfectly modeled with the shapes that we know. And I had students come up with some different ideas about how to calculate the volume using cylinders, cones, parts of cones, spheres, cool stuff like that. So it's one of the things that they do. We're going to talk about this task some more. So here's a cross-section of a nail, and the students are going to need to find the volume of that nail, and then we're going to get a little bit more into that. So it's task heavy. It's students come in and they dig into a task. There's not the lecture at the beginning. They're not doing 25 of the same type of problem, and I really like that, but it obviously comes with some drawbacks as well. Finally, here are a couple more questions that have to do with volume. They're finding the volume of the silo. They're figuring out how much grain can be filled in this silo. These are the geometric modeling problems that students see. Now, here's to the heart of the presentation. Are they modeling according to what the research says good modeling is? Is this a good use of modeling? Are they missing pieces? Are there things we're not hitting on? So here's the task that has to do with the nails. So nails are sold by the pound, and you're going to build a deck. And we know that the deck requires 24 planks. The plank requires 9 nails. We know the density of the steel, and then how many ounces are in the pound. And so what our students are expected to do is, given that cross-section of a nail and these other bits and pieces of information, how many pounds of nails should we buy at the hardware store? Giving you a second to kind of fill that all in. Okay? And then here is the cross-section of the nail that they have. So they need to find the volume of this nail and then determine how many nails are going to be needed to build this deck. Okay? So let's think about this task, and we'll think about what aspects of modeling are really evident and if there are pieces of the modeling framework that are missing. So the problem is there. Okay, so the problem is pretty easily identified. We need to know how many pounds of nails to buy. Okay, next, make assumptions and define the essential variables. Here's where I think this task is a little bit lacking. It doesn't require students to make many assumptions. The information's given to them. They know how many ounces, they even know how many ounces are in a pound. They know the density of the steel. They know exactly how many planks it's going to take to build this deck. So I think that this task could be a richer example of modeling if so much information wasn't laid out for students very, very quickly. Now that might happen because this is just one tiny little snapshot of a larger unit based in a larger curriculum, but if this is going to be something that's richly modeling, I think that it gives a little too much away. Students can do the math, they can report their solutions. Students can iterate as needed. I really like using the 5 practices in my classroom, so students might need to go back and realize that they made a mistake and they need to try something else. And then they're going to analyze that model and the solutions. They're going to look at other student solutions and see what they kind of come up with. So while I think this task really hits richly on several aspects of modeling, and I think is infinitely better than giving them 20 cones and weird shapes to find the volume of, I think it's a lot better than that. I think that it's giving a lot away for students, and I think it kind of takes away the authenticity that might be occurring because there's just so much information already given. So I think this problem's a little too well defined, and students don't need to make assumptions. I'm also thinking, is finding this answer important? Could I actually have, I work at Penna, I can have construction students come in here and tell me how big the deck is, and maybe they need to find how many planks, or maybe they need to research how many nails need to get put in a plank. Maybe they shouldn't be given the volume of steel. Maybe they should have to ask, well, what material is this made out of? So that we're driving the idea behind density. I think there are a lot of things that could be richer. I think that those aspects might take away from the amount of time students spend doing calculations. But I think that's a good thing. I think it's a good thing that students would have to ask those questions. So I think this is a helpful starting point for what geometric modeling could look like. According to the game report, maybe this isn't quite as rich as it could be. And I think that's true of many tasks that we do in geometry. I've got some resources here for you that I was taking a look at. Mathematics teacher and all of those resources are really rich. And then I also really drew a lot from that panel. Dan Meyer was on that panel in the Mathematics Science Research Institute, and it's definitely worth checking out. I appreciate your time. It's been a great semester. Thank you very much.